All right, so we're going to be talking about dividing polynomials. And when we're dividing polynomials, the first one we're going to look at is dividing by a single monomial. And when you're dividing by a monomial, what you're looking at is how many times can that individual monomial go into every single term. And so what we're going to do is we're going to create a bunch of smaller fractions. So here's our first example. So it says the quantity 9x cubed minus 6x squared plus 15x quantity divided by 3x squared. And so what I did is since I divided, remember when we're dividing by fractions, we can multiply by its reciprocal. And so that's what I did right here. And the reason I did this is because I'm going to kind of move this in as a fraction. So I'm going to multiply all these numbers by 1 over 3x squared. And so what I get here is I get 9x cubed over 3x squared minus 6x squared over 3x squared plus 15x over 3x squared. And now I'm going to simplify within each one of those. Okay? And so I'm going to be looking at how many times does the coefficient reduce down and how many times does the variable reduce. So I look here, 3 goes into 9 3 times, and x squared. So there's 2 x's on the bottom, there's 3 x's on top. So this is going to cancel, 2 of these x's here are going to cancel out with 2 of the x's up there, leaving me with 1. So this ends up with being 3x. And so now I get minus, well, 6 divided by 3 is 2. And now I have x squared over x squared. Well, x squared over x squared is 1. I don't have to write it, I can leave it. Plus, now I have where I have the denominator has a higher power. Okay? But I'm still going to look at 15 divided by 3. Well, 15 divided by 3 is 5. And so that's going to go in the top. That's going to go in my numerator. And I have x on top and I have x squared on the bottom. So one of the x's on top is going to cancel with one of the x's in the denominator, leaving me with an x in that denominator. And so this is my simplified dividing polynomial. Okay? We're going to look at binomials next, dividing by binomials. So just to reiterate, remember that when you're dividing the monomial, you're going to divide every single piece by that monomial. Okay? So our next example, we're going to divide 3d squared minus 4d plus 13 divided by the quantity d plus 3. So what I'm going to do is I'm going to show you algebraic long division. Right? So we're going to set this up. If you remember back into elementary, long division, we're going to set it up pretty much the same way. Okay? But now instead of dividing just numbers, we're going to be dividing by variables. And so what we're going to do is we're going to look at my dividing binomial, and I'm going to work with my lead coefficient, or my lead term, my lead term there, and I'm going to look at what causes this to equal this. So d times what is going to give me 3d squared? Well, there's 1d here, so 1 times what gives me 3, that's a 3. D times what gives me d squared? That's a d. So 3d times d is going to give me 3d squared. So I'm going to take this 3d and I'm going to multiply it by every single piece of what I'm dividing by. So 3d times d is 3d squared. 3d times 3 is 9d. And this is going to be plus because they're plus here. But remember when you're doing long division in elementary, when you got to this part, the next piece was to subtract them. So I put parentheses around this just to remind myself that I want to subtract this, because a lot of times if this is a negative, we tend to forget that we are actually subtracting it. Okay? So 3d squared minus 3d squared is 0. So I'm not going to write it, but there's a 0 there. I have negative 4d minus 9d, which is going to give me negative 13d. Okay? Right? And then I'm going to bring my 13 down. So plus 13. Okay? Now, d times what is going to give me negative 13d? So d times negative 13. So I'm going to take this negative 13, I'm going to multiply d, and I'm going to multiply 3. So negative 13 times d is negative 13d. Negative 13 times 3 is negative 39. And remember, you're going to be subtracting those. Okay? So negative 13d minus a negative 13d, that's going to cause that to become positive. So that gives me 0. 13 minus a negative, that's going to turn that to a positive. So I really have 13 plus 39, which is going to give me 52. Okay? So that's my remainder. If you remember, you have your remainder down there. So if I want to rewrite this, what I'm going to do is I'm going to rewrite this as 39 minus 13 plus 52 over d plus 3. So I have this fraction, this last little fraction part there. Okay. So we're still going to be multiplying or dividing by binomials. We got 2 more examples. The first one, if you notice here, here's our quantity here. I have quantity 18z cubed minus 8z plus 2 divided by the quantity 3z minus 1. Now the unique thing about this part here is it's missing a z term. So it's missing the z squared term. And so when we set up our long division, we want to make sure that we have a placeholder. So we have 3z minus 1, 18z cubed. Well, how many z squares do we have here? Well, we don't have any. Okay, so there are no z squareds. So mathematically, I have 0z squared minus 8z plus 2. And now I'm going to divide. So 3z times what gives me 18z cubed? Well, 3 times what gives me 18? That's 6. Z times what gives me z cubed? Z squared. So now I'm going to take this 6z squared, I'm going to multiply it by each piece here. So that's going to give me 18z cubed minus 6z squared. And remember, you're going to subtract those. Okay, so I'm going to put a parenthesis around those again. 8z cubed minus 18z cubed, that gives me 0. 0 minus a negative, that's going to make it positive. 0 plus 6z squared is 6z squared. I'm going to pull down my next item here. You could pull down both, it doesn't really matter. I'm going to leave it up there for now, just so I can see that there's just 2 pieces here. I'm going to look at 3z times what is going to give me 6z squared. So I know z times z gives me z squared. Okay. 3 times what gives me 6, that's 2. It's a positive, so I want to make that a positive. So 2z times 3z is 6z squared. 2z times negative 1 is minus 2z. Put that in parentheses and put in my subtraction sign out front. 6z squared minus 6z squared gives me nothing, gives me a 0. Negative 8z minus minus, this becomes plus, so negative 8z plus 6z is negative 6z. I'm now going to bring down my 2, plus 2. So 3z times what gives me negative 6z? Well, that's going to be negative 2, because I got to get from 3 to negative 6. So negative 2, I already have the z, so I have negative 2. Negative 2 times 3z is negative 6z. Negative 2 times negative 1 is positive 2. And I'm going to subtract this. Well, if I have the exact same thing subtracting, I end up with 0. So 3z minus 1 divides evenly into 18z cubed minus 8z plus 2. This is what it divides to. Okay? So this times this is going to give us that. Okay? Now, on our last example, I put this up here because they just kind of rearranged everything. And so we typically like to have our lead terms be in the lead. Here we notice that the x squared term is the last term. Well, it doesn't matter. You can just rearrange that. Okay? So I'm going to divide these out. I'm going to set up my long division. And as I'm setting it up, I'm going to rearrange these in the right order. So this becomes 2x minus 3 divided Okay, so it's going to divide this, and I'm just going to rearrange it. So I'm going to put it from highest power to lowest power. 4x squared minus 10x minus 1. And now I'm going to divide. 2x times what gives me 4x squared? Well, I know x times x gives me x squared, so that's x. 2 times what gives you 4? 2. So 2x times 2x will give me 4x squared. 2x times negative 3 gives me negative 6x. And now I'm going to subtract these. Okay, so the 4x squared cancel out, they go away. I have negative 10x minus minus, this makes it a positive 6x. So I have negative 10x plus 6x, which is going to give me negative 4x minus 1. I now need to get 2x, I need to multiply 2x by something to get it to be negative 4x. Well, I already have the x's, so I'm just multiplying by a constant. 2 times what gives me negative 4? It's a negative 2. So negative 2 times this whole piece. Negative 2 times 2x is negative 4x. Negative 2 times negative 3 is positive 6. With my parentheses, I'm going to subtract that. Okay. So the negative 4, the 4x's are going to cancel out. I have negative 1 minus 6, which gives me negative 7. Or 2x minus 2 minus 7 over 2x minus 3. Be careful, where I see the most mistakes is they subtract the first one and then forget to subtract the second item here. That's where most mistakes occur. That's why I put parentheses around this to remind myself to subtract both of them, not just that first piece. So that's dividing polynomials.